Okay, good evening, guys, and thank you for not for going home, and welcome to a little bit more boring things, talking about routing and so on. First of all, I'd like to thank guys at City Network for fixing a computer to me, because when I came here I was not thinking about that my flash drive could be a source of potential breach. But yeah, the more I stand here, the more I understood that it was a stupid idea. But anyway, thank you guys once again. My name is Iurii. I work at apparently Baloo. And first of all, I'd like to say that it's been a while since I was running a presentation, so I beg your pardon for possible delays in my explanations, and as well for possible bad English, because I'm not that good in it as well. So yeah, while you were listening for me, it was some little information about Baloo, but yeah, here it comes. Yeah. That would be weird. It's not every day you meet a routing person, and I'm a routing person or network technician, who is talking about network and not security, not, I don't know, network function virtualization or anything like that. So, yeah, sorry, there will be nothing of rocket science today. No new functions as well. There will be no result in the end. And sorry guys, I work for the competitor. But I think without this last slide, this would be not that fun. I mean, all of the rest of the presentation will be just boring thing. Okay, out of us, who don't know what is BGP and why do we use it? Great. It makes internet happen. So everything what we know in when we open up mobile phone and go to google.com, more or less in the bottom, it is a task of BGP to deliver content to you. I will not dive into much details. We can discuss it personally, but yeah, that's the only protocol which exists, and rest of the things are for those who are a little bit more convenient with the term. It would be easier to say why we don't need BGP. I mean, it's just a couple of situations when we don't need it. In any other situation, you need it. So, when we came to understanding that BGP is important, we came to idea how it works. So, of course, every network technician, and me as well, have its own point of view how network should be built, and every new network technician will say, the guy who was before me have done shit here. It need to be completely revised. But it is a high-level overview of how inter-service provider communication could look like. So we have our service provider here, and we have our upstream service provider, and border devices are exchanging some routing information. Our device apparently is saying information that these networks are reachable there, somewhere here, and service provider, upstream service provider is saying, okay, internet is reachable there. And in the bottom, all we want to see is these things, next hops, where we will need to send information to reach some destination. What we will be running inside of autonomous system or inside of our organization is not that much of interest currently, but it's some internal protocol. Okay, user traffic, believe me or not, it flows irrelevant of your decisions. Will it be BGP, will it be any other kind of protocol? It flows. It can work even with static routing, but we are here after BGP and some answers just because BGP is so cool. That's what I think. Okay. I haven't said it, but we are here for price optimization, and in order to answer why do we need it, another question would be what we try to solve. My idea was, can we reduce the cost of the solution? And if we are running this El Clasico design of physical devices which are capable of running 10G plus speed, it costs around $40,000. I'm not sure about Cisco because I was not working a lot with it last years, but approximately $40,000. Okay, so this is something what I would like to reduce. So which alternatives which alternatives exist already? We can run reduced so-called collapsed core or collapsed edge, and ultimately result that core devices or switches or whatsoever is running eBGP. In this situation we are exchanging partial view between from our upstream provider and supplying to upstream provider still the same information about our own autonomous system. Yeah, the only thing which we need to pay in this situation is license cost, because BGP is advanced feature which requires advanced license. Another possible solution to this will be to run BGP on some VM, which is a little bit offloading the brain of our core device, but still requires the same advanced license, which is lower than price with the hardware devices, but still a little bit on your pocket or out of your pocket. So, in order to proceed, we need to ask our couple important questions. So why do we need the iBGP session? I'll just run a little back here. So this would be ideal design without this part, because it requires some cost investments. So why do we need it? The answer is very simple. Just because BGP allows us to pass non-directly connected next hop. If I will roll back here, the whole idea was that control session is running between these two devices and user traffic is still flowing here, and we are able to pass both next hops of the router B and core A between each other. So very simple, and would we be able to solve that? That would be a win of at least $8,000 in case of Cisco Nexus. So the solution to our task would be to run eBGP on some kind of VM or some very cheap server, and IGP or a little bit tweaked IGP between this server and the core devices. My internal tests showed that the task, which takes like 2 or 3 minutes for high-end internet device, takes just under 1 minute for the VM. And that is because we don't need to process entire routing table and put it into the kernel. We need just information, so it takes as much time as to receive like 20 or 30 megabytes of information, which is internet full view. Okay, so our conclusions gives us this topology that we are still running eBGP session between routing VM and upstream provider server, which is quite nice because BGP allows us to send non-directly connected next hop, or eventually that's the beauty of BGP and routing manipulation. We can send virtually anything we want. Yes, no problems. The only problem is here with this purple arrow is that internal gateway routing protocols were not designed to run between non-directly connected devices, and all of you knows apparently about that, because it's only a guy who didn't know about BGP. So yeah, the only thing we need is to change this thing, because by default this routing server will send its own address as a next hop, which will allow us to save a little bit in our own pocket. Possible solutions which didn't work. As we are all talking about as we are all talking in the same language, with except of one guy, whom I will explain everything. So we have couple possible points where we have impact on what and how is sent, which is, for example, during redistribution. So we could change the next hop during redistribution, which is not working. We could change an next hop during export of OSPF routes out of routing server, which is not working. We could import or change next hop during import of OSPF on the target core device, which is not working. As well, Juniper devices, and I believe Cisco as well, allows you to manipulate what you are putting into the forwarding table. Unfortunately, not that much, and that is not possible as well. One of the possible solutions would be to manipulate with IP route module, which is responsible for routing information generation in the Linux, which I'm not that experienced of, but probably it's possible. And another definite solution would be to use CAPI, which allows you to generate virtually any kind of packet to dynamically intercept OSPF package. We know what we need to change and where we need to change, and we have CAPI to do that. So, do that. As I promised, there is no definite result. So, if you have questions, please ask me now. Yes?
I looked at the comment below. You said you tested with Bird, Quagga, and Juniper.
Yep.
What does it mean? You tested it only on server or actual network devices running Quagga, Bird?
Actual network devices running Quagga and Bird, and Juniper, which was physical device. This one was EX4500 and 4550. Anything more? If you don't know this guy, that is a guy who always says challenge accepted, and this is How I Met Your Mother series. So here you are, accept this challenge, and thank you for attention.